All right, guys. Welcome to 1050. Nope, 1040. This is a statistics class, which is unlike any math class you have ever taken. It's not really math. The hardest thing, they really changed the curriculum this year, so I don't know if this is entirely true. But the hardest actual mathematics you would have to do in this class is basically solve for x, which would be, and it turns out you don't even need to do that. If you don't know how to do it, you would be just fine. So with this year, I don't really know. It's a totally new curriculum. Like we threw our old textbooks away. The textbooks are online. It's going to be totally different. But this is not an algebra class. This is not a math class. Really, the hardest thing you're going to be doing is squaring numbers, subtracting by 5, taking the square root. It's not at all math specific. But it does require a lot of thinking. And some kids who are really good at following directions have a hard time in statistics. And some kids that don't think they're good at mathematics do fabulously well in statistics because, like I said, this is not a math class. It counts for your math credit in college for many, many degrees, but it's not even called a mathematics class. It's under the stat department, so it's statistics 1040. So you have to have a 19 on the math ACT to get into this class. That's new this year. We've never dealt with that before. And if you want the college credit, you have to apply to USU Eastern, or USU, I guess, which is like 50 bucks. Does that sound right? But you only have to apply once, and it covers all of your high school college credits, and it also covers if you go to USU in the future. So this class, I believe, is 3 credit hours, and they will charge you $5 per credit hour. So this class will cost you $15. And I took a stats class at BYU in the summer once, and 20 years ago, that cost me $512. And the prices have gone way up since then. So if you can get this credit here in high school, you will save a ton of money. Also, you're going to save a lot of time. When you take this class in college, they meet for 50 minutes, 3 days a week for 3.5 months, September, October, November, and half of December. So 50 minutes, 3 times a week for 3.5 months. We are going to meet 5 days a week for 70 minutes for 9 months, which means as long as you work in class, you will never have homework. Now, if you miss a day, I guess you'll have to make that up. But we will do everything we can in class. Now, this new book I said is a little bit different, so I'm not exactly sure how it's going to turn out. But my hope is I will never, ever, ever assign you homework. Unless it's like data gathering. I might tell you, you need to, on social media, you need to get 200 people to answer this survey or answer this question, that kind of stuff. Okay. What else do you need to know? You're going to, this is going to stretch your brain a little bit for a lot of you. And typically we have a lot of kids that transfer out of this class. For whatever reason, it happens. I'm going to try to avoid that. I'll do everything I can to help you understand, but you need to let me know if you don't get it. Like if you're lost, this is not a class where you can pick it up later. If you don't understand the basics, we're gonna learn the basics and then do it over and over and over in different ways. And if you don't get, if you're totally lost, let me know, because you don't want to go a week or 2 weeks without understanding it, because it's going to build and build and build and build. And like I said, none of the calculations are difficult, but this class is all about, can you look at a situation and figure out what you're looking at and what you need to do with it? And then the formulas are super easy. They're just, a lot of times you just ask the calculator, hey, tell me the answer. But you need to know which question to ask because the computer doesn't know. All right. So I'm going to start with an assignment. I'm going to hand this out. Oh, shoot. I have somebody else's assignment. All right. So I will hand this out. I want you not to talk to your neighbor, and I want you not to turn it over. So only look at the front side. And Garrett, I will email this to you, but I'll get it up on the screen so that everybody can see it. Recent. All right, Malia, you're going to the counselor's office. So just if you figure out the front, then do the back. You'll figure it out. It's not too hard. Okay, so here is the question. Suppose a county has an election and they have counted 87% of all eligible voting ballots that have been submitted. So they have a giant box. They know how many are in the box. And they're one by one going through and logging the votes. Right now, they have finished 87% of the box. The results are shown. Now, there are only two options. You either vote for X or you vote for Y, and blank is not an option. You have to vote for either X or Y. Okay? So, candidate X has received 1,365,217 votes, and candidate Y has received just over 1 million votes. So right now, candidate X is winning candidate Y by what? About 300,000 votes, right? So as of this moment, candidate X has 56% of the votes, and candidate Y has 43% of the votes. So my question to you is it possible that candidate Y can still win the election? Candidate Y is losing. Can they still win? Okay. So I'm going to pause the video. So Garrett, go ahead and answer that question. Don't flip to the backside. I want you to just work by yourself, spend a little bit of time, see if you can figure out the answer. Don't get any help. Okay. So Garrett, you won't be able to do this, but now I want you to compare with the people around you, see if you kind of got the same answer, and figure out how they calculated that and see if you calculated it any differently. I'm going to pause the video again. All right. So I heard a lot of yeses. I heard a couple no's. Okay. How many of you said yes? How many of you said no? Who's right? Okay. So I want you to turn it over. Now, pay really close attention to the way that I calculate this, because if you did something differently, I want to know so that I can share it with everybody else. All right? Now, in statistics, we're going to do a lot of stuff wrong. A lot of stuff wrong. And the majority of my job here is to decondition you, uncondition you. You have been taught that certain things are the way they are because the people who told you don't understand statistics, which is really scary. The average person has no idea how statistics works. In fact, a lot of times when you hear people say, "Oh, I read a study that said," no, they didn't. No, they read a report about a study, and the person who read the study doesn't understand statistics. Most of the time, the people who wrote the study do understand statistics, although that's not a guarantee. So I have to unteach you all sorts of things, and I can't unteach something that I don't know you know wrong. Okay? So we need correct examples and incorrect examples. So if you did something differently, please share it with us. We'll only make fun of you a little bit, but you have to unlearn so much in order to understand statistics because it's weird. It is totally weird. And a lot of things exist that are completely counterintuitive, but they're actually true. So we're going to, I'm going to need, well, I'll keep this up and then I'll just use a paper. All right. So one way to look at this, if you look at the back, is how many total votes are there? How are we going to figure out how many total votes there are? Add these two together, okay? And, oh, I need to do this. So if I add those two together, what do I get? 2, somebody read it off to me. 2, 4, okay, let's do it this way. You tell me. 2, 4. Okay, everybody agree? So that represents everybody that has voted and been counted. Okay, now what? I need the remaining 13%. How do we do that? So could I just increase it by 13%? Could I just say this times 1.13? Will that work? No, it doesn't work that way. So if you have a total and you lose 13%, and now you're down to 2.4 million, is 13% of 2.4 million the same as 13% of the original amount? No, my value is now smaller. So I can't do that. I cannot times by 1.13 and get the correct answer. So one way to look at it is if I took some amount and I times it by 0.87, that should equal 2413022. So how would I calculate that? Divide by 0.87. Okay. And when I do that, I should get, oh, I guess I can just do it from here. I should get the number, I don't want to reveal all the answers. Oh, it's the wrong, I didn't have answers to all the questions, so. Quick, quick, he showed us the answer. Okay, so what does that give me, David? 2.7, 2.7. Okay. 0.5. What do we do with the 0.5? Really, what do we do with 0.5? Round up? How come? You can't have half a person, I agree. What if it was 0.4? Even short people are a full person. And extra tall people don't count as more than one. So you round up or down? I don't know. But we certainly can't have 0.4 of a person. Okay. Well, that's a problem we're not going to solve today. All right. So there is that number. Okay. So how do you win this election? I guess I have a calculator. Why don't I pull my calculator up? You have to get what? So, oh, that's a good thing. So, if you look at this, I'm interested to see if that will work. Let's do it this way, and then we'll come back to that. That's really intriguing. I like yappers. Okay. So, in order to win, you have to have a majority, right? So if I take 2773588, oh, I messed up. 2773588, and I divide that by 2. So if I had that many votes, would I win? No, what would happen? I would be tied, right? And I still could win because every election at some point comes down to a coin flip. That actually happened in the Emory School District. So there was an open school board position in Orangeville and half of Castledale, and in Utah the elections are ballot elections, and so the ballot has to be postmarked by the election date. So if you wake up election morning and you have not voted yet, you can hurry and fill out your ballot, take it down to the post office, and if they stamp it as election day, then our post office will take it to Provo and they'll sort it, and then they'll send it back to whatever town you're in. Yes, that's how the mail works here. And then it'll be counted. So it took several days for these ballots to come in, and the race was close and close and close and close, and they ended up that they were within a couple votes of each other, which triggered a mandatory. Oh, good, we are recording. Triggered a mandatory recount. They recounted and they recounted and they recounted, and it was dead even. And so they drew straws, literally drew straws. They took 2 straws, cut a long one and a short one. Somebody held them between their hands, and somebody picked, and the winner got to stay. That actually happened not too long ago. Okay, so that is not enough to win. So we're going to add 1. Okay? So the question says, how many votes are necessary to win? That's the number. 1386795. Okay. If I did my math right. So, how many of the remaining votes would candidate Y need to get in order to win? How do we figure that out? So far, Y, let's bring that back up. All right. So far, Y has received that many votes right here. So to figure out how many more they need to win, we just need to subtract the total needed from that amount. So minus 1047. I saw some of you erasing. Don't erase. We might need your mistake. Or maybe it wasn't a mistake. All right. 338990. Got it? Okay. So, can we answer the question? Does candidate Y have any hope of winning the election? The question's over, right? What's the answer? The answer is yes. As long as candidate Y gets that many votes, they will win. Are there that many votes left? Well, there'd have to be, otherwise that number would be negative, right? So we have 2773588 minus the already counted ones, 2413022. So, does candidate Y have any hope for winning? Yeah. Okay, but that's not my last question. Do you feel like that is likely? David says no. Yeah, but you wouldn't be able to do that, right? You'd have no idea how to. So if you started counting all of the Y peoples and now, or X peoples, and now you're counting the Y votes, Like if you were able to do that, there wouldn't be any point in counting them anyway because you've already separated them. But we don't know what's in the box. So why are you saying no? Okay, good. So thus far, the population tends to favor candidate X slightly, not huge, but slightly more. So would we expect the remaining ballots in the box to be the same or different from what we've already seen? They should be about the same, right? Now, that's not entirely true everywhere because um, Tom Hansen was in an election this year and he narrowly lost to the incumbent from Price. But he was getting counted Emery County, Carbon County, and Duchesne, parts of Duchesne County. Now, Emery County voted heavily in favor of Tom Hansen. Carbon County did not, and Duchesne County was kind of mixed. So if the remaining votes were from a specific place, they might not be the same, but we'll just assume that they're not. So how well would candidate Y have to do in order to win? Pretty good. What percentage of the remaining votes would Y have to get in order to win? What was that? I don't know what I'm. Is that our bell? I don't know. uh, morning activity, fourth. Oh, we switched lunch, huh? I have no idea. Do you want to poke your head out, see if people are running around? Okay. All right. Whew. Oh, no. You can stop panicking. Yeah, I don't think that was the bell. That was too soon. Okay. So what percentage of the remaining votes does Y have to win in order to beat X? So Y needs 338. Oh, I did it again. So 338990. And how many are left? 360566. What does that mean? So in order for Y to win, 94% of the votes in the bin would have to be in their favor. What do you think the chance of that is? So thus far, Y has only got 43% of the votes that we've counted. So what is the chance that of the remaining votes, 94%, more than 94% would be in favor of Y? That's extremely unlikely, right? Okay. So let's answer the question again. Does Y have any hope of winning the election? That's a hard question, right? Yeah. So there, yeah, what a weird situation, right? Well, welcome to statistics. So here's the crazy thing about statistics is there is no answer. In mathematics, there is an answer a lot of times, not all the time, but a lot of times there's an answer. And in statistics, any answer works a lot of the time. So, is there a chance that Y wins? Yes. It's not impossible. Is it likely? No, it's not. So which answer is correct? Both. So um, if you take any data set and you hit it hard enough with a stick, you can get it to say what you want without telling a lie. Now, it's really easy to lie, but with any data set, if you beat it hard enough, you will find something that backs up your position no matter what your position is. And you can report that as fact without telling a lie. Now, it might be completely misleading, but it's not untrue. So if I ran up to candidate Y and I said, "Hey, buddy, you can still win this thing." Is that a lie? No. Is it true? Not really. I mean, the probability of it happening is essentially zero, right? So if I run up to you and said that lottery ticket could be the winning ticket, is that a lie? No. Is it the winning ticket? Probably not. So Mark Twain said it best. Mark Twain said there are 3 types of lies in this world. And he rates them in order of severity. So he says there are 3 types of lies in the world. First, you have lies. Second, you have damned lies. And third, you have statistics. Statistics can be completely misleading without speaking any falsehood. Okay? So in my case, I would say no. The answer to this question is no. Y does not have a chance. Numerically, it's possible, but the probability of it happening is essentially zero. It could happen. You know, maybe the cards just got shuffled in a way that there are a whole bunch of Ys at the bottom of the box. There's no way to know. The cool thing about being a statistician is you never have to tell anybody what you really think. It's like, imagine you had a square of Jell-O and like a whole thing of Jell-O, and you nailed it to the wall. That Jell-O is going to slide right around the nail and fall off the wall. You cannot pin a statistician up against the wall because they never tell you they're sure about anything. They always say, definitely, maybe. Is there a chance of winning? Definitely, maybe. Yes, there's a 100% chance it could be true. So statistics is the art of the definite maybe. There is no right answer, right? Yes is true. No is true. So everybody gets an A, maybe. Okay, so I want to know how you guys attack this in a different way. So I've already forgotten your name. Oh, okay. Did anybody do it in a different way? So you subtracted which ones? So you added 13 to this to get to 50? Or what was your... Oh, so you wanted to equal that. Oh, and then you did... Okay. So is there a way to do this? So what she did was she said the difference between these was 13.2, right? No? Oh, okay. Yeah, that's not going to work. Is that the real bell? She said 208, right? Not the right bell. Okay, so just save these till tomorrow.